Hi guys, today we're going to learn decimal to binary. Okay, so what we first need to know is binary and its root. So we could think about like bikini, which is like a double two-piece swimsuit. So beanie is derived from Latin and it means 2 by 2. Or just think about like bikini. Or you could think about binarius. Which just means two things. So, binary, binarius, or you just think two, bin, I don't know. So, yeah. Okay, so let's actually learn what 1 and 0 even means. 1 means on, and 0 means off, like a light switch. A light bulb going on, or a light bulb slowly turning off. So that's all we need to know. So let's move on. First, let's try something simple, like decimal is 3. Okay, so for binary, what we need to know is that each number doubles itself. So 1, let's just say double that is 2. 2 is 4, 4 is 8, 8 is 16, 16 is 32, and 32 is 64. You just multiply each of them by 2. Or you add one of them, so like, yeah, you get the gist. So if the decimal number is 3, and 1 equals on, and 0 equals off, what does that even mean? Like, what? So let's think about it like this. Can the number go into 1? 3 is bigger than 1, so we can use 1. So 1 is on, like we can use it. So we're applying 1 to the situation. So 1 is on. Okay, so 2 is left in 3 now. We can use 2. 2 is on. Now we got our 3 because 2 plus 1 equals 3. And the rest are too big to even put into the number 3. So we put zeros, because we won't use them. But the thing about these zeros, you don't need to put them in here, because there's no 1 turning a number on. So these zeros don't matter. So the final answer is just 1, 1. So 11 in binary equals 3 in decimal. Oh my god. Let's try something harder. Let's say we get like 72 is our decimal. So let's say 1, 2, 2 doubled is 4, 4 doubled is 8, 8 doubled is 16, 16 doubled is 32, 32 doubled is 64, and 64 doubled because 64 is still not greater than 72. When you always need the number in front of it to be greater, you put 128. Okay, so you always start with this side. So can we put, we always start with our left side. Can we put 128 into it? No. Can we put 64 into it? Okay, then we put 64 into it. And then 64 can go in, so it's on, because 1 equals on, 0 equals off. And then 32 is too big, so we can't put an on 0 and put on 32. So then you put, so 64 plus 16. That would be 80. That's bigger than 72, so we also don't use this. Can we use 8? 64 plus 8 equals 72. So then we can turn this one on. And now we already have 72, so let's just put zeros right here. Perfect. So we don't need this 0 because there's nothing on in front of it. But we have to use all of these zeros. So we have 1, 0, 0, 1, 0, 0, 0. That equals 72 in this. Okay, now let's see how to convert binary to decimal. So first we need to set it up. So let's say we have 1, 0, 1, 1, 0, 1, 0. I wonder what number that is. So let's set it up. We need 1. We need 1, 2, 4, 8, 16, 32, 64. So we have 0, but it's given to us as 0, 1, 0, 1, 1, 0, 1. Okay. 1 equals on and 0 equals off. Then let's just add these numbers that are on to each other. So we have 64 plus 16 plus 8 plus 2. Okay, so we already know 80 plus 10. And then that would just give us 90. And we can double check our work by saying if the number is 90, what would this be? 2, 4, 8, 16, 32, 64, 90, 0, no, 1. Can 32 go? No. Can 16 go? Yes. Can 8 go? Yes. Can 4 go? No. 2, yes, yes. And that is what we had. Anyways, bye guys. I hope you guys learned something. Okay, then we put 60.